All right, everybody. This is Mr. Ainsworth. We're going to get into some quiz corrections on how to solve quadratic equations. So, obviously, have your notes out. Okay, I'm talking about your Unit 6 notes. All right, you're going to need those. So, take out Unit 6. All right, notes. Okay, on solving quadratics. All right, that will obviously help you there. And so, let's label this. Let me see. Section in your notes. We started with factoring, all right? So this is section 6.1. Square roots is section 6.2. Completing the square was section 6.3. And this is section 6.4. So use your notes effectively, all right? Be smart, get those out first. If you need a calculator, get that out, and that might assist you. I don't know. Uh, so here we go. All right, and you're obviously gonna do this in your spiral. Get some graph paper because you're gonna have to submit this on Monday when you come in and take your retake. All right, so do a little practice here. This is a video, so if you need to pause and play, obviously use that effectively. All right, so pause and play, and also use the rewind button. All right, rewind. Why? Well, because if you have to listen to it twice and I go too fast, well, then use it effectively and go slow, go at your own pace, and do a good job. All right, so let's get right into it here. All right, we're going to solve by factoring, and you can solve by factoring. Always look for a GCF. Okay, so let's write that down too. All right, right here I don't have a constant term. It's not a full quadratic. So you always want to look what they have in common. So in this one here, you want to factor out GCF, and that is, by the way, the first technique that you ever learned in terms of factoring. It is the most common technique. So factor out, all right, to GCF. All right, since 28 and 8 are both divisible by 4, I can factor out a 4. All right, that's part of the GCF. They also have an x in common. So what I want to do is factor out a 4x, not just 4. All right, I want to factor out a 4x. So I get 4x times 2x will give me an 8x squared. 4 times 2 is usually 8, and x times x is x squared. You can also use division here too. So 8x squared divided by 4x is 2x. All right, minus because there's a minus sign. And then 4x times 7 will give you 28x, and that's equal to 0. And my friends, that is called a zero product. Okay, so let's write that down. Hang on for a second. Let me there we go. All right, so this is called a zero product. Ooh, that's too thick. All right, way too thick. Hang on. Timeout. Zero product here. And if you look at your notes in factoring, the zero product rule was used in every simple or in every example when it came to factoring. All right, it states this: if you have two things where they multiply to 0, one of these has to be equal to 0, all right? Something times something equals 0. It's a zero product. So either 4x equals 0, all right, or 2x minus 7 equals 0. Well, 4 times what is 0? I mean, just think about it. 4 times what number equals 0? And the answer has to be 0. I mean, you could divide both sides by 4 and do the algebra, but if you just think about it, you're going to get 0. And then 2x minus 7 equals 0. Well, let's add 7. Let's do a little bit of algebra here. And you get 2x equals 7. Divide by 2, and you get 7 halves. So x equals 7 halves, or 3.5. So we get two results here. We get x equals 0, and you get x equals 7 halves. You have to use the zero product rule when it comes to any factoring problem, all right, when you solve equations. Even on the second one. This is a full quadratic. We got a quadratic term, 2x squared. We got a minus 7, that's a constant, and we got equals 5x. And this is not in standard form. All right, so you have to put it in standard form. So let's do that. Standard form meaning that it's equal to 0, because you got to create a zero product, right? You need standard form. All right, that means you got to set it equal to 0. All right, so which is what I'm doing. Now, I noticed that some of you guys did not write this in descending order, so you got to do that too. So 2x squared, not minus 7 minus 5x, which some of you guys did. You got to go minus 5x minus 7 equals 0. It's got to be standard form where the degrees are decreasing or in descending order. Second degree, first degree, and then the constant. Some of you guys got these two terms mixed up, and it was all incorrect. So you got to be careful there. And then you got to be thinking, okay, all right, what two numbers multiply to 2 times negative 7, which is negative 14, and add to a negative 5. Kick in your factoring concepts back in the prior unit. Okay, so what two numbers multiply to 14? Well, you got 1 to 14. All right, 1 times 14 and 2 times 7 here, but they have to multiply to negative 14 and add to a negative 5. So if you make the 7 negative, like 2 times negative 7, you get a negative 14, and 2 plus negative 7 gives you a negative 5. So let's do a little factor by grouping here. Let's split the middle term. Okay, all right. Negative 5x is 2x minus 5x. Excuse me, 2x minus 7x is negative 5x. I just split the middle term right there. I just rewrote the equation. Let me highlight this. So right here, whoops, sorry, gotta rewind here. Where's my highlighter? Right here. So this portion right here, the middle term, I just rewrote it as 2x minus 7x. That's minus 5x. All right, just rewrote that. Now, first group here, I got to factor out a 2x. Factor by grouping, remember? All right, 2x times x is 2x squared. 2x times 1 is 2x. On the second group here, this group here, they both contain a negative 7, so I'm going to factor out a negative 7. Notice that the binomials are in common right here, this binomial. So I'm going to start off with x plus 1. All right, and then multiply it by the remaining terms, which are right here, the 2x minus 7. So times 2x minus 7. All right, and that's equal to 0. Bring down the 0. The zero products is important because this equation wouldn't have solutions if it didn't equal to 0, or if it didn't equal to some value. You got to get to the zero product stage. All right, and then you set each one equal to 0. So x plus 1 equals 0, which means x equals negative 1. And then 2x minus 7 equals 0. Okay, and then if you do that, holy cow, you get the same answer as above up here. So you get 3 halves. So x equals 3 halves. Excuse me, 7 halves. 7 divided by 2. So there you go. So you got two solutions there, negative 1 and 7 halves. So you got to get that zero product rule going. Okay. Now, when you don't have a middle term, all right, when there's no middle term, like in all of these examples, it is possible to isolate the square term, okay? So go back to section 2 notes, okay? Section 2 notes, and notice that b equals 0 in these example, okay? There's no middle term. All right, so let's continue here. So in this case right here, when there's no middle term, it is possible to isolate the squared term. All right, so let's write that down. All right, if you look at your notes, that's step 1. All right, so isolate, all right, the squared term. In this case, it's the x squared term, or in this third case right here, it's the binomial squared. All right, or the binomial squared, so x minus something squared. It's either one, so you just isolate it. All right, the keyword is isolate, and then use square roots like the directions say right there. So let's do that. So let's isolate the term. Let's highlight the x squared. It's right here. X squared is right there. It's being multiplied by 8 and then added to 64. So the very first step is to add the opposite. And you get 8x squared equals negative 64. And then divide by 8. All right, and you get x squared equals negative 8. I saw a lot of people square root the 8x squared, and that's not correct. You guys got to isolate it first and then use squared root. So the step 1, you isolate, and then step 2, all right, you square root both sides. Square root, all right, both sides. If you look in your notes, that's what it says. That's what we did all those times. You just have to review the techniques. So let's do that. Let's square root here. Oh, let's back up for a second. All right, now if you take a look at this right here, we already have an issue if you think about it. So you got to stop and think. You know, x squared is positive and it's equal to negative 8. All right, so this is positive and this is negative. You think that's possible? All right, a positive cannot be equal to negative. All right, and that's why this case right here, there's no real solution. All right, if you try to take the square root, do this on your calculator. Take the square root of negative 8. All right, it's going to say not real. All right, there's, oops, I meant no real solution. There's a solution, but it's imaginary. All right, so no real solution. It's imaginary. You're going to learn about that in Algebra 2 when you get there in a couple of years. You're going to study that new set of numbers called imaginary numbers. All right, so let's continue. All right, so on this one here, isolate the x squared term. So subtract 8. Add the opposite. So you get negative 2 squared equals negative 8. And by the way, some people just saw that, end up with a negative here, and they said no real solution. No, you got to think about it. You got to isolate the squared term. So you're not done yet. You got to divide by negative 2, and you get x squared equals 4. What are the two numbers squared that equal 4? Where they're 2 and negative 2. 2 squared is 4, negative 2 squared is 4. All right, so x is equal to plus or minus 2. What does that mean? Well, it means 2 and negative 2, guys. Two solutions here. If you want to square root both sides, go for it. All right, do that. Square root of 4 is 2. It was simple as that. Okay, now in this one here, on the third one here, the same thing. You got to isolate the binomial. All right, I'm talking about this portion right here. So let's do it. Let's add 24. Let's add the opposite. All right. Be careful. Do not distribute through the 2 like some of you guys did. That's the illegal move. You never multiply before you square. You always handle the exponents first. So that would be an illegal move, distributing through the 2, which I saw on the quiz. So don't ever do that. All right, no bueno. Okay. Now you're not done isolating the binomial squared. You got to isolate the squared term, which in this case is a binomial. So you simply divide by 2. All right, and you get x minus 3 quantity squared equals 12. Okay. And then you square root both sides. All right, so you square root this side and square root this side. Put the plus or minus symbol in because you got two solutions here. All right, the square root cancels out the square, give you x minus 3. Inverse operations like that always do that. They always cancel each other out. Is equal to plus or minus rad 12. Now let's go over here off to the side. You got to simplify the root. So the factor pairs for 12 are 1 times 12, 2 times 6, and 3 times 4. All right, for 12. Well, 4 is your only square, so you square root the 4 times the square root of 3, and you get 2 rad 3. So you simplify the root. As we always do, go back into your previous unit. We did that every single time when we practice simplifying roots. All right, and then you add 3 and you're done. So the answer is x equals 3 right here, plus or minus 2 rad 3. All right. And that is how the game is played. All right. Okay. Now let's take a look at number 3 here, or number 2. Oh, I'm going out of order. Who cares? Okay. Completing the square. Now, in completing the square, the lead coefficient must be 1. So let's write that down, okay? Lead coefficient, that's this number right here, all right? Must be 1. Must be equal to 1. And it's not. If you go back to section 3 notes, all right? All right, look at the third example here in our lesson notes, all right? It has to be 1. Even in example 1, I said the lead coefficient must be 1 to complete the square. And so if you just take 12 and divide by 2 and square it and start working on completing the square, you're not going to get the correct answers. All right, so the very first step is to make it 1, right? Do something simple like divide everything through by 2. All right, so what do you get? Let me see, these cancel and you get x squared plus 6x minus 11 equals 0. And then you start your process. Get the constant on the right-hand side. All right, and you get x squared plus 6x plus something, leave room to complete the square, is equal to 11 plus something. Now, when it comes to completing the square, this concept right here, it's always b divided by 2 quantity squared, where b is the middle coefficient, and in this case, b is 6. It's right there. So you got to take 6 divided by 2 and square it. So what is 3 squared? Well, it's 9. So you got to add 9 to both sides. Okay. I mean, in algebra, you got to be balanced. You got to add it to both sides. All right. And so 11 to 9 is 20. And then you got to factor the left side because completing the square makes it factorable. That's the whole point of it. All right. It's a perfect square trinomial. So do you know two numbers that multiply to 9 and add to 3? two numbers that multiply to 9, and add to 6. I was thinking of the answer there. Well, 3 times 3 gives you 9, and 3 plus 3 is 6. It's always this number right here. When you take half of b, that's the number that you use in factoring. So you have x squared plus 3x plus 3x. Notice that I just rewrote the middle term. 3x plus 3x is 6x. Plus 9 equals 20. 11 and 9 is 20. Factor by grouping here. So x times x plus 3. Factor out a 3 here because the 3 is in common. It's called a GCF right there. X plus 3 is in common, so factor it again. Now when you complete the square, the binomials are always the same. It's a perfect square trinomial, and so you will always get x plus 3 quantity squared. You always get a binomial squared. And the reason why that's cool is because we just did it down here. Whenever you have a binomial squared, all you do is square root both sides, like in down here number 3. So you square root both sides. That's why I taught this technique first, all right, before the completing the square technique, because you need it. All right, so you get x plus 3 is equal to whatever plus or minus rad 20 is. So rad 20 is root 4 times root 5, which is 2 rad 5. So you get plus or minus 2 rad 5. All right, subtract 3 and you're done. All right, and you get x is equal to negative 3 plus or minus 2 rad 5. Or 2 root 5, either one. And you remember, quadratics can give you up to 2 solutions, either 2 solutions, 1 solution, or none, right? You may not have a solution like, let me see, where was it? This one right here. In number 3, it was not real. Okay, it happens to be imaginary, which you'll study later. Okay, now quadratic formula time. Okay, so you got to know it, right? So in order to use it, you have to know it. So you have to memorize this. So I'll put it over here. Now I found out by, obviously grading your quizzes that a few of you did not know the formula, and because of that, you couldn't apply it. So you have to memorize this thing. So it's negative b, the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2 times a. You got to memorize this bad boy, because you can't apply what you do not know. Okay? So in here, and by the way, this only works if, okay, ax squared plus bx plus c equals 0. You have to set it equal to 0 first in order to use it. And hey, I was nice to you. I gave 1 equal to 0. So a is 1, all right, b is negative 2, and c is negative 4. All right, a is 1, b is negative 2, c is negative 4. All right, so here we go. So x is equal to the opposite of b, so the opposite of negative 2, plus or minus the square root of negative 2 squared, all right, minus 4 times a times c, all divided by 2 times a. So we simplify that. The opposite of negative 2 is positive 2. Negative 2 squared is 4. Negative 4 times 1 times negative 4 is positive 16. And then 2 times 1 is obviously 2. So when you simplify this, you get 2 plus or minus rad 20, all right, divided by 2. And I saw people in the quiz, divide 20 by 2 here. You can't divide a root by a non-root. That'd be an illegal move, dividing these two things, all right? So you got to simplify first, all right? And the square root of 20 here is the square root of 4 times the square root of 5, which is 2 rad 5, all right? So what you want to do is you want to simplify it. So root 20 is 2 rad 5 divided by 2. And then you simplify, all right? You get 1 here, divide them all by 2. All right, GCF of those three terms is 2. And you get x is equal to 1 plus or minus rad 5. 1 plus or minus rad 5. You don't need to put it over 1 because dividing by 1 doesn't do anything. And by the way, 1 rad 5, you never write the 1 there. 1 times rad 5 is rad 5. Okay? So you have to memorize the quadratic formula. You have to know when to use roots, okay? You use square roots when b is equal to 0. If you didn't know that, look back in your notes. In the very first beginning, I said when b equals 0, okay, you can isolate the square term. When there's no middle term, use roots. If there is a middle term, well, then try factoring. If it's not factorable, try completing the square, because that always works. You can use that at any time you want. And if you don't like completing the square, well, then use a quadratic formula every single time. This will solve any quadratic. Completing the square will solve any quadratic, but sometimes the middle term is not even and it's odd. And when it's odd, it becomes more difficult. That's what I meant to say. It's not impossible. Okay, you just have to work with fractions. All right, so most people don't use the complete the square method when the middle coefficient is odd. They switch to the quadratic formula because it becomes easier. So you have to know what to do. You have to know when to look for a GCF. All right, if there's no constant term like in the first one here, look for a GCF and factor it out. Always look for a GCF. All right, if it doesn't have a GCF, try factoring. If it can't be factored, all right, then you have to switch to completing the square or quadratic formula. You have to know what to do, okay, and that takes practice. So I would suggest to you guys a simple thing, all right? I would practice each one of these, and this is what I want to see you guys do, and you're going to provide evidence on this, all right? So practice, all right, each one. I'm talking about these previous problems, all right? Each one of these, all right? 3 to 5 times each, all right, to develop mastery. Because I found over 28 years of teaching that, believe it or not, and I've seen this happen so many times, hundreds, if not thousands of times, that a student can correct their work and they don't practice and they make the same mistakes again. All right, and then they don't even improve their scores. Why? Because they haven't developed mastery. They haven't really figured this stuff out. It hasn't been committed to memory. It hasn't been like the light bulb has not gone on. And the light bulb goes on through practice. All right. And that is what you need. Okay. So practice doesn't make perfect. All right. Perfect practice makes perfect. So you got to practice each one of these 3 to 5 times each. I would run through all of them and then run through all of them again. I wouldn't do it each one, 3 times in a row and then switch to the next problem. I would go through the whole set and then check yourself, and then go through the whole set again and then check yourself and then go through the whole set again until you can get it right, like perfectly step by step. All right. And by the way, don't skip steps when you practice. All right. Do things like you've never seen it before, step by step, and practice the correct way. And if you do really well. If you don't, okay, obviously you won't improve. So you have to focus in on proper study habits, better practice until the light bulb goes on, until you start really understanding this material. And by the way, do it like I do, step by step. Don't skip anything. Right? Do not step or skip any steps. All right, and you do that, you're going to improve, I promise you. All right. Well, I'm done now, and the only thing you need to do is do your practice. So go ahead and get started, and I'll see you in class. All right, bye-bye.